Hello everyone and welcome in today's video. On our last video we explained how to solve by hand calculation this frame which we have here, an L-shaped frame with the following parameters, and we solved it parametrically so we can use it in the future if some of these parameters are going or these variables are going to change. Today I'm going to model this question on robot in order for us to understand how to, let's say, do some modeling and how to use the software, and of course to check the results of our hand calculation as we showed on the last video. So today we will model this frame, and for that let's just start a new project. And as mentioned in the videos, these are 2D problems, therefore we need to choose this frame to design option here. We click that, and now the first thing which we need to start is to model our structure based on the data which is given to us, and for that we need to assign some members, and we can go by the members which the software is automatically providing to us. It doesn't matter that much as we are not designing the members or checking them if they have enough capacity to carry the load. The purpose of this exercise is to understand how to solve the questions or the exercise which was given to us by software and checking the results. As mentioned in the end of the last video, that these are going to be the parameters for which we are going to check the results, and we need to model based on these parameters. So let's start by modeling our frame, which basically we have this data A, B, and C. So let's start first by modeling these A plus B, which obviously is going to be 10 meters. We can do that in many different ways, and I will show you two of them, and whichever you like you can do it. So one of them would be to model them separately, meaning that from point A to from point 0 we have this A which is going to be 2 meters, and let's check again B which was 8 meters, and then we can start from this point 2 and then go to the coordinate of 10, and in that way we are going to have these two separate members. This is going to be 2 and this is going to be 8. Another method, I will just show you how to model it so you can understand much more better how the software works. Another method, it can be that we can model the whole frame or the whole beam, actually in this case, as we already know that it's 10 meters. And of course we need to cut this member 2 meters away from the starting point, and to do that there is these options for which we need to show them in order for us to edit the members. We go to tools, we go to customize, and we click show toolbars. And in this one, as you can see, the edit bar is hidden and we need to turn that on. And after that we close, and as we can see we have the edit box here for which we can drag it and place it here. And as you can see here, there are different options for which we can use. For example, this one is to move or copy. These two are for mirror. And for our case, we are going to need to divide this member. And for that one, we are going to choose this option which says division. We click that, and there are different options for which we can cut the members. For example, we can cut it into parts, into distance, or we can cut it by plane or in relative distance from the member edge or length. What we are interested is that we need to cut from a specific distance, meaning that it can cut from point 0 and we need to cut at location 2 meters. Therefore, as you can see here, we give this distance 2 meters, we press, and now we go to our members, and as you can see here we have this arrow which indicates the direction to which the member is going to be cut, and if we click here it's going to cut from 0 to this direction, and it's going to generate this node which is going to be our node. For this case it's numbered as node 3. Still the member is as 1, but for example if you want to cut the member as well, we can select this node and delete. And what we need to do is that we need to untick this box here which says generate nodes without member or edge division, and in that way we are going to generate a node which is going to cut our member at this position 2 meters. We hit enter, and now as you can see this member is separate and this member is separate. For this purpose of exercise, actually it does not matter if these members are cut. We just need to have this node here at 2 meters in order for us to apply the load at this position. So after we do that, next we continue to model the other member. for which this distance is going to be 6 meters, and then we go from 0 to -6 downwards. After we model the members, the next step to be done is to model the supports, and at support A we have a roller. This is going to be the configuration for a roller, and now we select our node and we have this roller support here. At point C it was mentioned that we have a fixed support, and we click the node and we select the fixed support, and then we would have the fixed support. So now our frame is stable, and the next step to be done before applying the load is that we need to add a load case. So we just add some dead load, and now after we add the dead load we go to the load definition, and as on the previous exercise where we had distributed load, we would go to the member load, as that load is acting all over the members. But for this exercise we have a concentrated load, and in that way we can just apply it to a single node, which for this exercise is going to be node number 3 according to the software. And now we go to node, and as you can see here we have a nodal force for which we can apply a vertical force, horizontal force, or either also a bending moment. For this exercise it was mentioned that this concentrated load is 10 kilonewtons, and as the positive direction is upward we need to give the value minus 10 kilonewtons here. Now we are good to go and add this concentrated load to our node, and to see the value we turn this on. So this is a minus 10 kilonewton load added to our location, which we are required from the exercise. Just to make sure, we go to tools and we just create some dimension lines to see if everything is correct. Yes, and this should be 6. Okay, so now we have our structure ready, and the next thing to be done is to run the analysis by clicking this button here, and now the results are available. And as on the previous exercise, we need to be careful because when we run the analysis, it's taking into account the dead load coming from the members itself. Then we go to loads, and if we do not want to include the self weight, we just remove the dead load of the members, and then the system is going to be analyzed only based on the forces which we are given. We go to start, we run the analysis again, and now we have the results. So if we want to show the results, we go here, then diagram for members, and I always like, or I prefer this type of view settings for my results. We go to the reactions bar, and now as we have a fixed support here, we also need to show the bending moment value, and we have the forces on X and on Y, obviously. Do not forget to turn this button descriptions on, and now we click normalize, apply, and now we have the results of the frame. And now these results, we have to compare them with our hand calculations. So for the f of z according to the software, we got 7.66, and with hand calculation we got the same. Also the support reaction on X at this one, which in our hand calculation is Cx, is 0. If we check that everything is alright, then we have f of z, for which for us it's cy, it's 2.34, and we got 2.34 by hand calculations, and the bending moment at C is 3.43 by hand calculation, and on the software we got 3.43. This was the video for today. I really hope you enjoyed it. Thank you very much for your time. If you have any questions, leave them down in the comment section below, and do not forget to like, share, subscribe. See you on the next video.